Alright, so let's go back to what we were doing. So if A is congruent to B mod n and C is congruent to D mod n, then you have A plus C is congruent to B plus D, and you also have A times C is congruent to mod n. So let's prove this. So first of all, if A is congruent to B mod n and C is congruent to D mod n, then n divides A minus B and also C minus D. So that means that n times k1 is equal to A minus B, and n times k2 is C minus D. So that means that n times k1 plus k2 is equal to A plus C minus B plus D, which means that A plus C is congruent to B plus D mod n. Alright, so now let's go to the proof for the second property. So what we want to show, that the following is true, that n divides AC minus BD. So what do we know? We know that A is congruent to B and C is congruent to D. So what we can do is we can insert so what are we missing here? So let's see what we're missing. So we want to show, so that is, let me write it here, that is, we want to show that AC is congruent to BD mod n. So how do we show that? Well, there is a missing step that we should do here. That missing step is that we want to introduce a variable where that variable gets cancelled out as we move between different structures. So that's the main intuition. Sometimes when we move between different structures, when we move from one structure to another, we could have a bridge that like collapses, like as you move between one structure to another structure. And this happens all the time. That bridge could be even made of values of 0, right? So it's kind of unintuitive, but like it's really it's clear in the end, because sometimes you could end up getting like some kind of invisible ladder, where that ladder goes up and down. So then when it goes up and down, it cancels itself out once you do the operation. So that's the main intuition. So let's see that intuition. So we could write AC minus BD as AC plus 0 minus BD Of course, 0 doesn't do anything. So we have AC plus minus BC plus BC minus BD. And here we can factor C, A minus B, and we can factor a B, C minus D. And now we use the fact that that n divides a minus. So we use the fact that n divides a minus b, and n divides c minus d. So we end up getting that. We end up getting the following: c n times k1 plus b n times k2. So then we can factor an n, k1 plus b times k2, and so we get that, indeed we get that n divides AC minus BD. So yeah, that's the main intuition here. The main intuition is that let's say we have a tall building, and let's say we have like in the ground, we could go from one building to another building by the ground, right? But you could have you could also have a ladder that goes like top and then goes down, that connects the two building across. So you didn't really do much. You introduce something that resembles like going in the same direction as going from one building to another building. All right, so that's the main intuition here. Okay, so I will include more intuition as we go on, as like this is very important idea, this notion of adding zero structure to have things cancel out. So or actually, like let me just add here that sometimes when you go from one structure to another structure, you could add one structure connecting a building to another building, and then after that you could add the negation of the structure that connects the other building to the first building. But then if you have a building in the middle, then that zero structure doesn't get cancelled out, but it traps things in the middle, like the squeeze theorem. So that's the main idea. So I hope you guys enjoyed this idea, and I will see you in the next video. Bye.